This is 9.5, mean absolute deviation. The mean absolute deviation is an average of how much the data values differ from the mean. This is another form of variation. So for finding the mean absolute deviation, abbreviated to MAD, first you're going to find the mean of the data, just like normal. Then you're going to find the distance between each data value and the mean. Then find the sum of the distances from step 2. Then divide the sum from step 3 by the total number of data values. So let's find and interpret the mean absolute deviation of the data. So here's all my values. First, I'm going to find the mean. So add them all up, divide by 8, and you get 24 over 8, which is 3. Then to find step 2, so if I look at my dot plot, the mean is 3, that's in the middle. I can make another kind of dot plot where these show the distances each of these dots are from the mean. So the dot on 1 is 2 spots from 3. The 3 dots on 2 are each 1 unit away from 3, so they have little 1s there. And then you can see 4 is 1 spot away and 5 is 2 spots away. So then I'm going to take all those numbers, add them together, and then that sum is divided by the total number of values, which is 8. So in this case, the mean absolute deviation is 5/4, or 1.25. The table shows the number of runs allowed by a pitcher in his last 10 starts. Find the mean, median, and mean absolute deviation. To find the mean, add them all together and divide by the total number. Let's divide by 10. So the mean is 3.5. Then I'm going to find the median, so I put them in order from least to greatest, crossing off one number on the left, one number on the right, until I reach the middle, and I had 2 numbers in the middle, so between 4 and 4 is 4. Then to find the mean absolute deviation, find the distance between these numbers and the mean. So 0 is 3.5 away from 3.5. 2 is 1.5 away from 3.5. 4 is half. 5 is 1.5 away. 6 is 2.5 away. And 8 is 4.5 away from 3.5. Add them all together and divide by 10. So the mean absolute deviation is 2.4. So you're finding the distances between the values we are given and the mean. Then you add them all together and divide by the total number. Now we are going to find the mean, median, and mean absolute deviation of the number of runs allowed by pitcher B in his last 10 starts. Which measure can you use to distinguish the data from the data in example 2? And what can you conclude? So to find the mean, we get 35 over 10, which is 3.5. To find the median, working left, right, until I reach the middle, the median is 4. Then the mean absolute deviation, finding the distance of my data values from 3.5. 0 is 3.5 away, 2 is 1.5 away, 3 is half, 4 is half, 5 is 1.5, and 6 is 2.5 away. Add them all up, divide by 10, and the mean absolute deviation is 1.4. So the mean is the same, the median is the same, but the mean absolute deviation is different. So we can conclude that pitcher B was more consistent. He had a smaller mean absolute deviation,